Okay, I think we're live. I see that we're being live streamed. Great. So hello, everyone. My name is Jen Looper, and I'm a Principal Education Cloud Advocate at Microsoft. I'm delighted to be here to talk to all of you. My job at Microsoft is on the next generation team. We call ourselves the Next Gen team. We have a logo and everything. So my job is to really talk to students and talk to faculty and get an idea of what you're interested in learning. I particularly love building curriculum, building all kinds of curricula, lessons and projects and things to try to learn new things. So even if some of you today listening are out of school and maybe you're working in your jobs and you're an established professional, to me, you are still a student because you are here, you're listening and you're learning something new. So I take a very large definition of what my students are. And today you are all my students. So I'm really happy to be here. You can always follow me at Jen Looper on TikTok, on Twitter. Actually, I'm also on TikTok. I'm JavaScript Auntie on TikTok, but that's beside the point. So yes. Anyway, so I'm always happy to engage with anyone on social media. Just let me know if you have any questions and reach out. Always happy to chat. So today we're going to talk about applied machine learning with Onnx Runtime. Onnx is the open neural network exchange, and we'll talk a little bit about what that is and how to build machine learning models that you can use within your web apps. Now, I have a particular perspective about this talk. I'm really interested in applied machine learning. And what is applied machine learning? It's the kind of a work that bridges two fields, really. It bridges the app building, with JavaScript, with Python that we're all used to doing if you're someone who's like a front end or a back end developer, on the app development side, plus also the machine learning and data science fields, finding that convergence so that we can learn a little bit about what each side of the aisle is doing, so that the app builders can understand a little bit about the processes of the machine learning workers and all of the amazing data scientists over here, and so that the data scientists can understand a little bit of the needs and desires of app builders, of people who build applications. And I think this is really pertinent and necessary, especially now. So back about maybe 5 years ago, I had a tremendous number of apps in especially the iOS App Store. I had some in Android as well on Google Play, but a lot of us were, trying to monetize directly and make money and just enjoy delivering interesting mobile experiences for our iOS users. I have my iPhone here. I'm on a Mac. Everything's hunky-dory. Everything's peachy. But it's really not such an easy motion nowadays to create a mobile app and just publish it up to the iOS, to the App Store, or to Google Play as an Android developer, if you're developing cross-platform, which is what I was doing, to both of these stores. The field has gotten way, way, way more convoluted and complex. If you take a look at the #1 on the charts right now, of course, it's TikTok, and you have Instagram, YouTube, Snapchat, Gmail, Amazon Shopping, Facebook, and Messenger, and all of these apps are deceptively simple. They're really infused with intelligence. They're the ultimate smart apps. If anyone's on TikTok, it feels like it's reading your mind sometimes. And I have found myself watching a movie on TV, and then TikTok somehow understands what I'm watching and sends me clips of the same movie. It is absolutely surreal and eerie. And it's machine learning running in the background. It's all of this intelligence that's picking up our data, picking up our emotions, and picking up what we're doing and delivering what it presumes to be experiences that we're looking for. And it's actually a little bit scary, but it's also it's really difficult to build these as an indie developer, which is what I was, several years ago when the App Store was perfect for indie developers and we could all just launch interesting indie games and indie apps. I specialized in fitness apps, lots of fun stuff. I think those days are over because now we're in a moment in time where apps and web experiences have to be intelligent first. You have to lead with your machine learning algorithms. And my theory really is that the death of the indie developer has to do in part with this, with this complexity. This is really, really complicated stuff. And I'm not going to walk you through cloning TikTok. That would be completely beyond my superpowers, but we can at least get a little idea of some of the ways that you can infuse your apps with machine learning. And interestingly, I found a little quote from 2015, which is, not yesterday, it's a while ago, that the best shot at success for indie developers is to go work for the man. And that's what a lot of us wound up doing. I mean, here I am, Microsoft as the ultimate large corporation. But really, this has been happening for a little while, and I think it's worthwhile for us to go ahead and start understanding a little bit more of how to build smart apps. So if you were to build a new smart app, what would you do? How would you go about building it? What architectural decisions would guide you? And what technical stack would you use? I used to build cross-platform iOS and Android apps using NativeScript. You could use Flutter, React Native, Ionic, any of these amazing cross-platform solutions. You could build natively with, Xcode and what's the new way of building iOS? I haven't done this for a while. Or using, Java to build your native Android app. How would you make this decision? Would you build a native app? Would you build for the web? Bypassing the entire mobile app store experience. I think a lot of people are doing this because the web has become so much more capable in terms of the experiences it can deliver natively. Things like picking up your microphone, picking up your camera, and it's really straightforward and easy. And the browsers are starting to all kind of fall in line about the expectations that we need to create a good web experience. And also responsive design has come a long ways. We can, pretty quickly and easily create responsive layouts that will be, able to be run nicely and lightly on lower end phones. There's also the opportunity to build for a desktop app. There are many people, building for the desktop. So there's a lot of opportunities and ideas of how you would go about building a smart app. Personally, at this point in time, I would stick to the web. I think the web has the capabilities that we need nowadays to build, intelligent, smart, and machine learning infused applications. And I'm going to show you how to do that today. But we have a problem, right? We have a problem that web developers over here and machine learning engineers have completely different skills. They're trained completely differently. They go through different degrees in university, or they're self-trained in completely different stacks. And it's a really completely different skill set. So how can we make these two fields converge? We have, for example, web developers who are used to working with back-end engineers, when they're creating this kind of full stack solution. They're used to using DevOps to manage the delivery of their applications. They're used to working with designers, and prototypes and wireframes. They are working either as accessibility experts or with accessibility experts to create, a really great and usable user-facing website. So that's what, where the web developer's mindset is, how can I make my application usable and beautiful and functional for everyone? And on the other side, we have machine learning engineers, these amazing scientists who are used to this completely different world. They're used to working with data scientists and they're used to sourcing data and cleaning it and preparing it and training it up and iterating until they can create this nice, accurate machine learning model, which they then have to somehow deliver, either as a full piece of software, or they could, deploy it to some kind of endpoint and have the web application then point to that endpoint. So then we have a subfield of machine learning engineers called ML ops, the ops people who figure out how to, deliver this machine learning model and how to, correct it and make it stronger and more powerful. I can only imagine what the engineers at TikTok are doing. It's an incredible application and it learns from our actions all the time. So obviously they have a very robust ops that they're able to, retrain that model using algorithms that they're probably constantly tweaking. So it's a completely, and then, the people who are actually delivering the iOS and Android experience in TikTok, have a completely different, they probably are in a completely different department. But this separation doesn't necessarily have to happen. Oh, and by the way, web developers' language of preference would be something like, HTML, JavaScript, CSS, and then the ML engineers might be using something like Python to build up their models. So even different languages. So I have a pathological fear of bridges. This picture actually makes me nervous. I could watch my watch and watch my heart rate go up. I grew up in a small town and we had to cross a big river to get to the larger city, the Missouri River. And on our bridge, there were holes in the pavement. You could see straight down, and I'll never forget, in our station wagon, going over that bridge and just looking down at the river. It was terrifying. I think finally either the bridge fell down or they demolished it, but that bridge is no more, thank goodness, because it was really scary. But bridging divides, such as machine learning, engineering, and creating web apps, I don't think should be so terrifying. Let's not look down, let's look across, to try to get to that other side in a nice, clean way. So welcome to Applied Machine Learning. I'm an app developer. I'm very interested in, using some kind of machine learning technology to make my apps smarter, to make them respond better to my users. And how can I do that? Well, fortunately, there are some very interesting tools that have cropped up recently within, I'd say, the past 3-4 years. And a lot of them are starting from TensorFlow, which is Google's amazing open source machine learning platform, really. It's a platform, and people are building on top of it, as you'll see in the next few slides. And one of the solutions that's been built on top of the TensorFlow platform is TensorFlow.js, so the JavaScript port for TensorFlow. And it's a wonderful project. It's got a nice community around it, and there are all kinds of really interesting opportunities in this ecosystem. There's also Brain.js, which is a little bit separate. It's a little bit lighter weight. It's just a different way to bring in another JavaScript library into your web apps. And then there's Onnx, which is something that we have a heavy footprint in at Microsoft, but it's an open platform, so there are lots and lots of folks who are contributing to it. And Onnx, it's onnx.ai is the website, but what I'm going to talk about today is the runtime, because the runtime is what you can use to bring in Onnx-based models into your machine learning, into your web app. There is an NPM package that you can use as well. So we're gonna go ahead and take a look at this today. So let's think a little bit about TensorFlow.js. Like I said, this is a big ecosystem. There's a lot of excitement around it. It has some really cool integrations. If you go to the TensorFlow website, you'll see the TensorFlow.js page has some very, very nice demos. There's one that I screenshotted. It's the emoji scavenger hunt, and it runs right on your phone. It's not a mobile app. It's a web app designed to run on mobile. So what you do is it'll flash an emoji like a shoe, and you have to run through your house and identify the shoe, and then it'll give you a point. So it's something that gets you up and moving, and it's a really cool and fun scavenger hunt. It's using basic image recognition on a pre-trained model, and you can either train your model in the browser and do your inference, which is that motion of just discovering and identifying objects or identifying the patterns in the browser. Or you can use pre-trained models for something that we would call transfer learning. So the emoji scavenger hunt is probably using a pre-trained model with some other bits trained on top of it. So it's a neural network, and you can add layers of training on top of it. So these are all opportunities that TensorFlow.js has built in for you. Let me just take a look at, I'll just show you. So I'm going to do a couple switching around here. So let me just show you the TensorFlow website here. So it's this one, and you can see TensorFlow.js is a library for machine learning in JavaScript. And then it has all these ways you can either run existing models, retrain your models, or develop machine learning with JavaScript, which is kind of next level. So here are some cool demos, and then you can kind of dig in. There's a webcam controller. You can play Pac-Man using images trained in your browser. There's a lot of really fun stuff. This is a terrific website. Okay, so let me go back. All right, I'm going to flip back to my slides. Awesome. You can also try something like ML5.js. ML5.js is built on top of TensorFlow, which is built on top of TensorFlow. So TensorFlow.js on top of TensorFlow. So ML5.js is machine learning for the web in your web browser. And through some clever and exciting advancements, that's very vague, the folks building TensorFlow.js figured out that it's possible to use the web browser's graphics processing unit, the GPU, to do calculations. So they built this thing called ML5.js to make it very straightforward to do image recognition, sound analysis, and text analysis. So here's a little picture of a bird, and it identifies that it's a little robin, which is one of our familiar birds in the United States. Let me show you the website. So it is ML5, friendly machine learning for the web. It's a neighborly approach to creating and exploring artificial intelligence in the browser. So here it's built on top of TensorFlow, and it gives you some examples. And it's using MobileNet. MobileNet is one of these pre-trained models, and you can go ahead and just use it directly to predict images. For example, here it's using this kind of image recognition to take a look for a cat. And there's also some doodles that you can use with Quick Draw. So lots of fun to try. Also a great educational tool if you want to teach a little bit about artificial intelligence for new students of the topic. So that is ML5.js. There's also Magenta. This is one of my favorite projects. Magenta.js, also built on top of TensorFlow.js, built on top of TensorFlow. This is a great project, and you can make music and art in the browser. Magenta.js is, I believe, how they built Quick Draw, which is this crowdsourced doodling. It'll say, draw me a flower, and then you go in on your application and you draw a little flower, and then it'll pair it with another flower so you can see how well you did, something like that. But Magenta.js is a JavaScript API for using the pre-trained Magenta models in the browser. So it's built again with TensorFlow.js, which allows for GPU accelerated inference, but it really specializes in sound and art, especially sound. If you're interested in making artificial intelligence flavored music, I think that this is a really interesting project to try. Let me flip over to their website. This is fun. Here is Magenta, and they have some code pens that you can run. And their goal is really to close their loop between machine learning researchers and creative developers and traditional artists. So it's a wonderful project, endless trios. I actually am really interested in Arabic music. This is maybe the audience to talk about it, and I would love to use some of the makam to see if we can maybe play a piece of Arabic music and determine what mode it was written in. I think this would be really interesting. I don't know if it's possible. The problem with these kind of pre-trained models is that they're usually looking for, a small set of Western type of music. I think they trained on Mozart. I don't know. It's worth a try. I think we should try. It's just like the biggest problem with this project of mine is to source the data. So there's Makam World, and I was thinking of grabbing all the music, but anyway, this is beside the point. But it would be a really fun project, and maybe somebody wants to collaborate with me on this. So contact me if you're interested in making artificial intelligence Makam. That would be fun. Okay, so let's see. We'll go back to our PowerPoint. So that is fun. And then there's PoseNet. I love PoseNet. PoseNet can be used to estimate a single pose or multiple poses, the whole body or just the hand or just the face or the whole system. And you can do all kinds of really fun things. I made a TikTok trainer with PoseNet. So I put the image of the video, or the video itself, and then I put the pose analyzer over the video, and then I put a second video on the same screen and try to mimic the dances that TikTokers do, and then give myself a score of how close my pose was to the dancers. So it was a really fun project, but PoseNet is definitely worth a look. I don't know if it's an active development anymore from Google. It was like a little project that they did, but there's other opportunities to take a look at PoseNet. Sorry, I was just looking at the chat. Okay, let's see, I'm going to just go to the next slide. Brain.js, I just want to talk a little bit about Brain.js, which is a little bit different project. So Brain.js looks like this, and it's specifically allowing neural networks to run in JavaScript for browsers, and also you can use it with Node.js. So honestly, I haven't done a lot with this, but I've seen some very good presentations. And I think it's a nice way to take a look at how to use neural networks in the browsers. And you can do, write a children's book using a recurrent neural network, learn math. I could definitely use that. What is cryotherapy for? Oh my, rock, paper, scissors. That's a little bit more straightforward. So there's a lot of things you can try with Brain.js, and you can use images, text, you can use it for forecasting, which is very useful. But it does have some limited APIs, and it supports not that many models. So it's something that's like a beginner type of thing to try. And I think it's of interest for us as students. Let me go back. Okay, great. All right. However, should you train data in the browser? We've seen that these solutions like TensorFlow.js, it allows you to, what do they say? Let's see, they say there are 3 things you can do with TensorFlow.js. You can run existing models, off-the-shelf models, you can retrain existing models, and you can develop machine learning with JavaScript. I don't think this is the greatest use of JavaScript, honestly. I think it's going to be slow. I don't think the browser is a great environment for training data in the browser. I know people have tried this, but it really isn't something that you're going to use in production. This is not what a company would want you to be doing. This is maybe something you could try on your own. But I think that to make a proper machine learning model for something that could be used in production, you're going to want to have a little bit more robust training environment. So we're back to Python, let's face it. And you can learn enough Python as an app developer to become a little dangerous. So it's a straightforward high-level language, just like, well, JavaScript. I think it's a little more straightforward than JavaScript. JavaScript has some serious gotchas. But I think that you can go ahead and learn enough Python to get you through running notebooks, which is how a lot of machine learning engineers work. And they have this notebook, it's a .ipynb file. It's a Jupyter notebook, and you have little blocks that you can run gradually. And I'll show you what mine looks like for this project. Let's see. Let's go to VS Code. This is my notebook. And what it's doing is it's building a cuisine recommender. It's installing Scikit to Onnx. This will come back later in the presentation. But there's all kinds of things that it's doing as code blocks, and then you can also comment your elements here. So you're working between Markdown and Python, and you're just running. And you can run this actually right in Visual Studio Code using a kernel. You can see that I'm using Python 3.8.9 kernel. And it's all pretty easy to do and straightforward using a notebook to train up your machine learning model. And it's only, it's very few blocks, honestly, maybe 5 or 6 to run an entire machine learning model. So this is a notebook, but another thing you can do is avoid notebooks and just work straight with Python. And you would use a .py file, and you would take your data, train it up using the same code base, but outside the notebook environment. You can also do this in Visual Studio Code, and you can go ahead and train up your machine learning model and then convert it using TensorFlow.js with Python. You can convert that model for use on the web, and there's a little TensorFlow converter script that TensorFlow has provided, and you can use that. So that's one way of training up your data, converting it, and then using it. You'd be importing that model one way or another to your web app. Another solution, if you want to completely avoid Python, is using one of these services such as Lobe. Lobe.ai is a desktop application that you can use locally, and you can train up your data. It's It's specific for image recognition right now, although they're looking to maybe expand. But this is a free application. And if you want to just take a look at how to work with images, I recommend downloading lobe.ai. It's free, and you can use your own images. It allows you to open up a camera and take a video. Like if I wanted to train all on plants, I could, just run my camera around this room and train up on these different kinds of plants. And then it would break up your video into images. So that's a really, really cool thing that Lobe does. And again, it uses TensorFlow behind the scenes, but it also allows you to convert your model that you just trained up for use on the web. So you can take your train it on your own data and use, download your own model and use it in your own web application. So this is an excellent tool to use for image recognition. It's a beautiful interface. It's free. Why not give it a try? So I actually trained, I have a collection of antique lace, and I was able to make a machine learning model to determine what types of lace I was looking at. I'm really interested in textiles. And that was a really nice use case for that. It could be used in a museum, for example, to train up on its collections. Anyway, so this is another low-code tool that you can use if you want to dodge Python completely. However, I don't know if you've noticed a theme in everything I've been talking about, but I've been mentioning that a lot of these solutions use TensorFlow behind the scenes. And what if you don't want to use, what if you can't use TensorFlow? What if you're not allowed to use TensorFlow? What if you don't need to use neural networks for your project? So not every machine learning problem requires the use of neural networks. This is something that I think is really important to understand. And let me just mention that this entire presentation is taken from a lesson that I created on GitHub. We have a project called Machine Learning for Beginners. So if you go to GitHub, I'll give the link at the end, but aka.ms/ml-beginners, that entire curriculum of 24 lessons does not use neural networks, because you do not need neural networks for a lot of your machine learning problems. So if you're doing classic machine learning, which is what I'm doing right now, and just using some text data to train up some kind of classification algorithm, then you wouldn't need a neural network. So even though I'm using Onnx has neural network built in its name. You don't have to, you're not forced to use neural networks in this situation. But what's cool about Onnx is that it supports Scikit-Learn. So this is something that we use all the way through this curriculum. And this is what we're going to use today. So here's my challenge. Let's pretend that I work with a data science team. We don't use TensorFlow at all. Let's just pretend. We're crazy. We don't use TensorFlow at all because we really don't need it. We don't need that heavy solution. We don't need to use neural networks because we have just a basic text, little CSV of text-based data. We're not classifying images. We don't have a huge amount of data. So really, we can just use Scikit-Learn. Scikit is for Science Kit Learn, and it sounds like it's just a toy thing, but it's actually really powerful, and it has that learn piece in its name because the documentation is pretty good, and it's actually by just going through and building models using Scikit-Learn, you can get a pretty good education in classic machine learning. It's very, very nice. I think it also supports neural networks, but it's very detailed instructions on how to go about creating classic machine learning models without neural networks, without even artificial intelligence, right? Just plain old machine learning to figure out classes. So my question is, can I use a Scikit-Learn built model to power my website? And the answer is yes. Yes, you can. And we did. And I'm going to show you how. So what I did is I created a recipe recommending application. It's actually a cuisine recommending application. So what I've done is I've created it's a very ugly application because I didn't style it at all. But it has a bunch of little checkboxes of potential ingredients that I might find in my refrigerator. And if I check off something like fenugreek and cumin and click the button, what kind of cuisine can you make? I'm querying my machine learning model, and it's suggesting that with these ingredients, I might be able to cook something Indian, some kind of Indian cuisine today. So then I would be able to go to my Indian recipe book and say, hey, tonight I'm going to make some kind of biryani, and here's my ingredients, and here we go. So this is a very, very useful application for not very creative cooks. So let's see how we can build this using Scikit-Learn and the Onnx Runtime to make that web app. So going back to Scikit-Learn, take a look at scikit-learn.org. I will show you what it looks like. Where's my slides? Yes, here it is. Okay, so Scikit-Learn is this. And it just has this very nice kind of examples and documentation around the most basic machine learning tasks that you're going to be doing. Classification, which is what we're doing today. Regression, which will give you this idea of a continuous valued attribute associated with an object like stock prices. Clustering, can you group, does your data allow for groupings of of types of customers and what they're interested in? Very useful for a business. And then it gets, those are kind of the three big ones. And then there's some more kind of use cases, like when you need to select your model that you've trained in various ways. There's a lot of tools here. There's a lot of good stuff in Scikit-Learn. So take a look, and let me go back to slides, because interestingly, if you go to Kaggle, which is one of my favorite learning platforms, also by Google, they did a little survey, and their user base said that Scikit-Learn is their very favorite, what did they say? It's a framework. They called it a framework. So they said, this is our very favorite framework for building our models. Scikit-Learn came over TensorFlow. Interesting, right? And then we have XGBoost and Keras and PyTorch, and it goes down. Hugging Face is right in the middle. Hugging Face, keep an eye on Hugging Face for natural language processing. Very interesting project and company. Anyway, I digress. So Scikit-Learn, very good for simple, predictive data analysis. It is open source. It's accessible to everyone. It's very reusable, and it comes bundled with NumPy, SciPy, and Matplotlib, which are ways that you can crunch your data, you can clean your data, you can use Matplotlib to plot your data in interesting charts, right in your notebooks if you like. And then this is just mentioning the 2021 State of Data Science and Machine Learning Survey. It's the most popular machine learning framework. I think that's interesting. And right here is the link that I wanted to show you, aka.ms/ml-beginners. We use Scikit-Learn all the way through to teach all different kinds of concepts for learning classic machine learning. So please take a look and tell me what you think. All right. Let's talk about Onnx. Let me show you their website, which is here. And so there's two of them. There's Onnx AI, which is the Open Neural Network Exchange. Well, you don't have to use it for neural networks. And it's basically a way to, it's a type of model that you're going to build. You're going to build a .onnx model using your machine learning process. That's Onnx AI, and that's the full-fledged product. But running on top of that is the Onnx Runtime. I kind of like how the logo sort of like opens. It's kind of cute. The Onnx Runtime, there's an NPM package that you can use now. They had a new release, so it supports more of our tools that we need. And it really optimizes training, and it optimizes inferencing. And it's really nice that it supports all of these platforms, it supports hardware acceleration, and it supports JavaScript, yay, right there. And if you want to build a native application, it looks like it supports Android and iOS, very cool, and preview in the web browser. So there's really a lot of usefulness of the runtime, and it's coming along very nicely as a product. So Onnx defines a common set of operators, which are the building blocks of machine learning and deep learning models. And it's a common file format, which is helpful because if you're working in a company, you want some kind of standard available so that everyone will know what's going to be produced by that data science team and then tossed over to the web application people. So it allows AI developers to use models with a variety of frameworks, tools, runtimes, and compilers. And just note, again, you don't have to leverage neural networks to use Onnx. And you can develop in your preferred framework, like Scikit-Learn, without worrying about downstream inferencing implications, right? So it enables you to use your preferred framework with your chosen inference engine. So that's really, really helpful. Okay, let's keep going. So a really typical applied machine learning workflow is that you'd go ahead and clean your data using Python, right? Perhaps in a notebook environment, train your model using Scikit-Learn. And then there's another library that I used here. It's SKL, Scikit-Learn to Onnx, SKL to Onnx library. And that converts my model for use with the Onnx runtime. And then I just built a very basic web application for use with this model. And if you want to take this whole presentation as a lesson, here's the link in ML for Beginners. You can take a look. It's the classification. There's actually four lessons on classification for all of this good stuff. Okay, so what we're going to do is we're going to source some data from Kaggle, and it's data about different types of cuisines. And we're going to classify some, actually, it's more like ingredient data or recipe or cuisine data. So for example, I have a recipe for masala chai, delicious Indian tea, right? And it has, among other things, it includes tea, black tea, ginger, fennel seeds, nutmeg, cardamom, probably cinnamon, other types of spices, the spice tea. So the data looks like this. It's a long amount, like I think there's 100 potential ingredients, but it starts with cuisine in this column. So this is an Indian recipe, and it doesn't have chicken, salt, pepper, but it does have tea, cardamom, and fennel seeds. So all it's doing is giving a 0 for ingredients that it doesn't include and a 1 for ingredients that it does include. So it just, I think this data, I don't know, maybe scraped a couple of cookbooks and grabbed typical ingredients and classified them as Indian, Thai, Korean, Japanese, or Chinese. Those are the 5 categories. And then just went through and just said, you know, it has this, it has this, it has this, but not this, this, or this, and give 0s and 1s. So, and there's only about 700 data points. So that's how big the data set is. So all of this information is important to understand. You need, as an applied machine learning engineer, which is what I hope you will all become, you need to understand your data, where it's coming from, its strengths and its weaknesses, and the shape of the data, how it's looking, because you're going to need to clean and shape this data for use in your, in your applications. So the first thing we need to do is we need to clean our data. So we're going to drop common ingredients that apply to all of these recipes, such as rice, garlic, ginger. Everyone uses these in these 5 cuisines. So that's not going to give us any information that's usable by the machine learning model. So you can go ahead and just drop those. And there's a procedure in Python using pandas, I believe, to drop those ingredients. And then we need to balance our data. So if you take a look, and this is, again, you need to understand and do some data analysis before you start on any of this. So you need to take a look and see, look, we've got 799 Korean recipes, but 598 Indian, 442 Chinese, 320 Japanese, and only 289 Thai recipes. That's an unbalanced data set, so we need to do something about that. And we're going to go ahead and balance the data so that there are equal amounts of each cuisine represented. And if you take a look at the lessons that I mentioned, it shows you how to go about balancing. There's a little library that you can use to balance your data by kind of injecting your data set with some data so that you eventually have 799 data points for each one of those classes. So this is the hardest part. For us as web developers, for me as a web developer, this is confusing. So we have to build the model. So you already have a barrier of entry, which is that you may not be super comfortable with Python. And then you have to figure out how to run notebooks in VS Code, Visual Studio Code, or however you're going to do it, or using a .py file, a .python file. So that's already, you're already getting into perhaps unfamiliar territory if you're a JavaScript person like myself. But what we have to do, fortunately, is we can use some cheat sheets that have been produced, because what we need to do is to build our model, we have to do a 3-step process. We have to pick an algorithm with which to build your model, pick a classifier that will best suit the type of classification we need. And this is heavily dependent on the type of data we have. And then we have to pick a solver to optimize the results. So this is all part of the Scikit-Learn situation. This is what they're expecting you to be able to do. To do this, you have to understand your data, like I said. So in our case, we have a multi-class data set, and we're looking to predict one of 5 classes of cuisine. We have a small data set, only 799 or something, like 800 points. That's pretty small. And our data is labeled. You remember it was like aniseed, almond, angelica. So it's all in those columns, it's all labeled. That means that we can use supervised learning because we have labeled data. So that's one thing that's a little, at least we know that we need to do a basic classification task using supervised machine learning, and we need to use some kind of multi-class classification algorithm to build the machine learning model because we have 5 classes. Remember, we have Indian, Thai, Japanese, Chinese, Korean. So with that in mind, you can go ahead and take a look at this little cheat sheet here for multi-class classification. So this is a kind of classification that answers complex questions with multiple possible answers. So is this A or B or C or D? Is it Japanese, Korean, Thai, Chinese? So then we have to figure out what multi-class classification algorithm should we use. We don't want to bother with neural networks, so we can check off that multi-class neural network. We don't need the long training time. The data, there's just too small data. We have a clean, minimal data set. And also we're training locally in our notebooks, so we really don't want neural networks. That's too heavyweight for this task. There's another opportunity to use a 2-class classifier. So you see that one versus all multi-class box. That depends on a 2-class classifier. Is it green or black? Is it white or black? We have 5 classes. Remember, this is a multi-class situation, so we have more than 2. We could use a decision tree or a logistic regression. A decision tree might work. Logistic regression could work for multi-class data. Just note that multi-class boosted decision trees, which is the one at the bottom there in the blue box, it solves a different problem. That one is most suitable for non-parametric tasks. In other words, tasks that are designed to build rankings. We're not interested in that. We don't want to know if, this Indian food is better than that Indian food. We're not interested in that. We just want to know what type of cuisine. So we're going to check that off. So that leaves us with 2. Multi-class logistic regression and multi-class decision forest. So those are some opportunities. So we're going to go ahead and try logistic regression because it's kind of the most straightforward Scikit-Learn library to try. So we'll use logistic regression. And then the next thing we have to do is to pick a classifier. So when we ask Scikit-Learn to perform a multi-class logistic regression task, we have to tell it what multi-class option to use. And logistic regression is really designed to support binary classification, black or white. So we're going to use OVR, one versus rest, to better handle multi-class classification. So you can see how we have this classifier that we're using, multi-class, OVR. So we're going to go ahead and use that. And then we have one more thing we have to do. We have to create a solver. We have to choose a solver. What's a solver? The solver is what algorithm to use in the optimization problem. So not all solvers can be paired with all multi-class values. So we pick liblinear. We're going to pick liblinear as it's the one that best handles OVR classifiers according to the chart. So here we are. And you can just kind of look through this chart and pick which one you want. And here's where the experience of a machine learning engineer comes in because that person is not going to need these cheat sheets. They're just going to say, okay, I want to try this, that, and the other, and they can quickly iterate and figure out if a different solver works better. So here I used logistic regression with OVR with a liblinear solver. I created my model by using LR-fit, my training data, and then I go ahead and check its accuracy. I'm passing in, for example, for some recipe that has cilantro, onions, peas, potatoes, tomatoes, and vegetable oils, sounds like an Indian food. The model came back with 71% accuracy. It's 71% sure that that's an Indian recipe. That's okay. That's okay. And in real life, 70–80% accuracy is not too bad. Before I move on, I want to show another cheat sheet. This is the Scikit-Learn algorithm cheat sheet. And this will also help you decide, which algorithm to use. So you start at the orange start button. Then you say, okay, do I have more than 50 samples? I love that. If it's no, get more data. If it's yes, you have to predict, is it predicting a category? Yes, Indian, Japanese, whatever. Do you have labeled data? Yes. Okay, that's a classification algorithm that we need to use. Do we have fewer than 100K samples? Yes. So we're going to go to linear SVC. If that's not working and we have text data, you could try native Bayes, but we actually have numeric data, so we can try a k-neighbors classifier with SVC. So there's a whole kind of a thought process that you can use of how to go about picking your classification algorithm. So this is very, very helpful. And what you need to do is to try several iterations, try several solvers, and figure out which gives the best accuracy. So you're going to train your model and experiment with the classifiers and solvers that give you the best accuracy. So what I did is, the previous choice of logistic regression gave me 71% accuracy. I tried a support vector classifier, SVC, and that one gave me 83% accuracy. So not too bad. So following Scikit-Learn's suggestion, I went ahead and chose the SVC, support vector classifier, and that was a bit better for me. So that worked. So I rebuilt my model. You can see here I have my, this is the Scikit-Learn libraries that I needed to import. And I trained and I split up my data into training and test bundles. And then I trained the data using SVC with a linear kernel. And then I fit the data and asked for accuracy. And you can see here that it ran through my test set and was able to get decent accuracy. You can see the accuracy macro average in the 80s, weighted average in the 80s. It's not that bad. I think that's a workable model. Awesome. What's next? I have to convert my model after that because my job is not done. And now it's time to start throwing my stuff over the fence to the web people, right? So I use that little library called SKL to Onnx and import a couple libraries so that I can go ahead and create my model for use and for export. It'll save this. You'll use this Python to save a model.onnx file. And if you want to check the shape of your model, you can use a free tool called Netron, N-E-T-R-O-N, Netron, and it'll show you for inputting floats, which is these numerics, 380 potential opportunities. That's actually the size, that's the number of columns. There's 380 potential ingredients, and we're using that SVM classifier, and we're getting, for the 5-class question I have, the probabilities and the labels. So we need to know it's like Indian, 71%, Korean, 80%. Okay, great. That's the conversion process. And then the last piece, and for us on the web, this is the fun piece. We need to use the model in a web app. So I'm just using the CDN of Onnx Runtime here, using a script here. So I import the Onnx Runtime and build a web app with a series of checkboxes to feed ingredient data to an imported model. And I use an asynchronous function to start the inference, checking whether the checkboxes are checked. If they're checked, I'm going to go ahead and do some inference in the browser against my model, which is available in my web app. So let me just shift over to my Visual Studio Code. So here is the notebook. Here is the web app. It's very, very simple. And so all it is a bunch of checkboxes here, and I just did a few. There could be more, but each of these checkboxes has a value. This is 327 out of 380. This is 112 cumin. And then I go ahead and start inference once I click the button. And I go ahead and just check what the model is going to be suggesting is the correct answer. So here's that start inference. And if it's checked, you just try and test your data against your model. And that's really it. It's only 119 unstyled bits of HTML and JavaScript. The model is here, right here, available. Here is that cleaned cuisines. This is the data that was trained against. And why don't I go ahead and show you how this web app works to finish this presentation. So let's see, I think I have it running already. I use HTTP server. So let me just share the web app, which is, let's see, I guess it's this one. Okay, yeah, it's this guy. So I checked my refrigerator and I have, let's say, an apple and some sake and some cumin. Let's see. So probably because I said I had sake, it says you can enjoy Japanese cuisine today. I hope you can see that pop up. I'm wondering if you can see the pop-up. But anyway, if I uncheck sake and check fenugreek, it's going to say that you can enjoy Indian cuisine today. So these are all suggestions, and that's, you know, what you can cook tonight. I wonder if I check a pear and cumin. I bet you it's going to be Korean. Let's see. Oh, Indian. So anyway, it's pretty sure, given the data that I'm inputting, checking against the model, what kind of recipe I might be able to create given these ingredients. So it's really a recommendation engine that we just built on our own. We did it all by ourselves. We should be proud, right? Okay. Let me go back to the slides and I'll just finish up. We tried it out, and I don't know if you could see those pop-ups, but anyway, there's little pop-ups coming up here. It looks like this. And then I just want to thank you very much for your attention. You can always find me on Twitter at Jen Looper. You can email me at Microsoft. My personal website is jenlooper.com. You can also try this challenge yourself at AKAMS ML Beginners. And honestly, we're also looking for contributions to these repos. We're always looking for translations. And I think it's a great way to learn. Honestly, I think in this thing, there's 26 lessons now because we had someone contribute another time series lesson. Lots and lots of opportunities to learn. You can learn clustering, regression, classification, reinforcement learning, natural language processing, and time series. And then there's a lesson on applied machine learning, like where you find it in the wild, like in what industries and that kind of thing. So lots and lots and lots of content, all available for you for free. And I'm really happy to give you the opportunity to learn with us. So thank you so much for your attention. I hope you have an amazing day. And I'll be online for questions if anybody wants to chat in the chat or not. I feel like we should play some amazing music at this point. If anybody has chat, questions, I don't know if the chat is available for questions, but I'm happy to answer. Any Arab musicians on this stream? Because if you are, reach out and let's build some models around Makam. Makamworld.com used to be an amazing website for lots of samples. I studied Arabic violin for a little while with my mentor, who unfortunately has passed away. He was very old, but he's a wonderful, wonderful teacher. Q&A. And is this tool working good for beginners? I think yes, because as part of our beginner curriculum, I'm a web developer and I'm a self-taught web developer. So I think that anyone can learn anything if you try hard enough. So yes. Okay. Thanks, everyone.